Alright folks, here is a lesson on the quadratic formula and how to use this formula in order to find x-intercepts of quadratic functions of this form. Okay, and specifically speaking for today's lesson, we are going to be using this right here, okay, that quadratic formula, this quadratic function right here. Okay, so let's go ahead and get started. Okay, so let's say that we have this quadratic function right here. Okay, your step one is to identify your A's, B's, and C's. So let me go ahead and zoom in right here. Okay, and we have our A equal to -3, B equal to 4, C equals to 8. Okay, so the A's, B's, and C's are in this light purple color right here. Okay, step two is to plug it into the quadratic formula. So I copied the quadratic formula from the top to here, okay? And anywhere you see A's, B's, and C's, you go ahead and plug in these values into where you see A's, B's, and C's, and we get to this, okay? Now, the next step is to put this, whatever's inside the root, in your calculator, and in this case, I get 112. So this whole thing inside the root becomes 112, okay? To which you say, okay, well, how did you put that in your calculator? Okay, so using side hustle number 1, we are going to enter this in our calculator in this format over here, which is pretty much exactly what you see right here, except you put a caret right before the 2 to signify an exponent. And I want you to remember that the calculator button is a different button for negative signs as opposed to minus signs, okay? And so that's how we get from here, okay, to 112 inside the root, okay, through side hustle number 1. Now, we're going to further simplify the root 112 to 4 root 7, okay? And the way we do that is through side hustle number 2, okay? Side hustle number 2, which I like to call the ladder method, okay? I like to call that the ladder method. So how do we get from root 112 to 4 root 7 on the bottom over there? Well, let me show you. So root 112 to 4 root 7. We start with the 112 and start dividing it by prime numbers. And the most commonly used prime numbers are going to be 2, 3, 5, and sometimes 7. We rarely get to the higher prime numbers like 11, 13, 17, and 19. Okay, so we mostly hover between 2, 3, 5, and sometimes 7. So here I'm going to choose to divide 2 into 112. You could have chosen 7. Okay, 2 goes into 112 56 times. Okay, I'm going to choose to divide 2 into 56. Again, you can choose 7 here. Okay, so 2 goes into 56 28 times. Here I decide to choose 7. 7 goes into 28 4 times. And 2 goes into 4 2 times. So all these orange highlights written out horizontally becomes 2, 2, 7, 2, 2. And when you multiply these, you get 112. Okay, so root 112 can be rewritten as root 2 times 2 times 7 times 2 times 2, which is 112's prime factorization in order to use, or if we're going to use fancy math terms. Okay, now root 2 times root 2 is root 4. Root 2 times root 2 is root 4. Root 4 becomes a clean 2. Root 4 becomes a clean 2. The root 7 carries over here. 2 times 2 is 4, and again, the root 7 carries over. So that, folks, is how we get from root 112 to 4 root 7. Okay, again, go from root 112 to 4 root 7 via side hustle number 2, which is right here. Okay, and finally, we're just going to reduce the 4, 4, and 6, okay, by dividing by the greatest common factor, which is 2 in this case. Okay, so 4 divided by 2 gives you 2. 4 divided by 2 gives you 2. 6 divided by 2 gives you 3. And this right here is your your answer in precise form, which is the same thing as saying this is your x-intercepts in precise form. Okay, now this next part's optional. What I like to do is put this in Desmos because I'm a visual person and I want to see how the graph looks like, and more importantly, what the x-intercepts are. Okay, now let's zoom in. Okay, now, okay, after putting this in Desmos, I get this function right over here, which is what I call a frowny parabola, because it looks like a frowny face as opposed to a smiley, which opens upwards. So this opens downwards. And we can see the x-intercepts here, negative 1.09, blah, 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 and 2.43, blah, blah, blah. And to which you might say, hey, how does this correspond to these x-intercepts? Okay, well, the reason or how it correlates to these x-intercepts is through actually calculating this out using your calculator. So what I'm going to do is separate this into two scenarios, one with a plus and one with a minus. Okay, and then I'm going to enter this in your calculator with the numerator with parentheses around it, and then divide it by negative 3. I get 2.43, which matches up here. And again, here's the minus scenario. I'm going to enter in the numerator with parentheses around it, divide it by negative 3, and I get negative 1.10, which is pretty much this x-intercept right here. Okay, and now we can see that once we convert this into decimal form down here, we get these decimals that Desmos displays. Okay, and that pretty much sums up today's lesson. Let's do a quick recap. Okay, so basically, okay, we use the quadratic formula, which is right over here, to find the x-intercepts of quadratic functions. Okay, the specific quadratic function that we're using today, okay, is this right here. Okay, and the step 1 is to identify your A's, B's, and C's, which I have done so in these purple highlights. Okay, and then wherever you see A's, B's, and C's in your quadratic formula, you plug in the A's, B's, and C's that you identified. Okay, and you get this. Okay, and you get this version of you get this version of the quadratic formula. Okay, well, not this version. You get these numbers plugged into the quadratic formula. Okay, and now when you simplify what's inside the root, this becomes 112. Okay, 112 becomes 4 root 7. Okay, right here through the ladder method. Okay, right here. All right, and you further simplify this. Okay, by dividing by the greatest common factor, which in this case is 2. 4 divided by 2 is 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And these are your x-intercepts in precise form. Okay, I like to take it further, like I said, and input this original f of x into Desmos to visually see how f of x looks like, but also to see what the x-intercepts are. So these are the x-intercepts, and how we get from this precise form to this approximate form in decimals is by separating out into two scenarios and putting this in your calculator with parentheses around the numerator and dividing by the denominator, and thus we get these two x-intercepts right here. All right, folks, that wraps up today's lesson. Thank you for tuning in. In the next slide, I will link you to relevant YouTube videos. I always want to end with this reminder. If you don't get math or any subject, keep searching for that right teacher. Keep searching for that right method. Remember, we live in an age of nearly endless learning resources, especially online. You don't have to assume math is not for you. And on that note, I wish you persistence and perseverance on your journey to learning anything.